In this conversation, I dive into the future of home building with Aaron Small, co founder of Reframe Systems, about combining AI and robotics in the home construction industry. We explore the challenges of mass customization and the recent breakthroughs in software and flexible automation that are transforming how modular prefab homes can be built. This is a wide ranging discussion on housing, startup life, construction, and technology. For people who haven't heard of Reframe Systems, how would you describe what you're working on?
Reframe Systems is a vertically integrated home builder. We build multifamily housing that's very energy efficient, high performance, and low cost. And we do that in a factory. So we're building a network of micro factories that have robotic automation and software control that allow us to customize housing easily to fit site conditions and customer preferences all over the world. We're looking to scale rapidly and help address the housing crisis in the US. And we have a long-term goal of building 1 million housing units by 2045.
How old is Reframe Systems, and tell me about your role?
Reframe's early on its journey. We're 3 years in, just had our third birthday, and we're
Happy
just getting
birthday.
started. Yeah, thank you. Yeah, thank you. I'm a very proud parent of a 3-year-old, and we're basically just getting started. So we have a small factory in Andover, Massachusetts. It's about 17,000 square feet. We lovingly call it the garage, since it's a old contractor garage that we converted into a factory. And we're producing housing already. So we have one unit in the ground in Arlington, and we're just putting the finishing touches on a 3-story, 3-unit building in Somerville, with another one to follow, an identical one shortly thereafter. We've got most of our 1 million homes to go still. We're at the very beginning of the journey. I'm one of the co-founders of Reframe Systems. I lead 2 teams there. One is our factory operations team, everything that happens in the facility to produce work and get it out the door and ship to site. And then I also lead a team that does design automation and design engineering. And what that means to us is moving from an architectural design, relatively low fidelity plan that's required by cities and towns to approve the project, and moving that to a really high fidelity 3D model, bill of materials, shop drawings, all the artifacts that go to power the factory. And how good we can get at that transition is going to be a big part of our success.
What are the big problems you're trying to solve in the housing and construction space?
The big problem in construction is that every single project is a snowflake. There are 30,000 zoning jurisdictions in the US. Every single town has some control over what gets built there, and they each have their own rules. There are climate zones, seismic zones, customer preferences, which are often reflected in those zoning codes about how things should look. And then there's site conditions, the unique soil situation of a particular site means that unlike most other products we buy, there is no standardization at scale. And because of that, construction relies on this traditional method of a general contractor and subcontractors taking a rough set of plans and figuring it out as they go on site. We would never accept this for any other product. If you were buying your Honda Civic and the plan was like, hey, I'm just going to hire a car designer, they're going to design a custom car for me, and then we're going to go hire a mechanic and they're going to ship all the parts to my driveway, and then a team is going to come rain or shine over the course of several months, assemble this car in my driveway. Like, this would be ludicrous, and I think anybody realizes that this car would be insanely expensive and clearly worse quality than something you could buy on the market. But this is what we do with housing every day, not because we haven't figured out mass production. We know this exists, but because the market doesn't allow us to do that. And so that's really the problem we're trying to solve is, how do you do mass customization at scale in the housing space? How do you solve this problem of building a snowflake every time, but doing it at a speed and cost that looks more like an industrialized process?
So, how do you think about that? I mean, have there been sort of process engineering breakthroughs or technological breakthroughs that make this possible now that maybe it previously wasn't possible?
Industrializing construction has been attempted for 60 years. I mean, there was the Sears catalog. You could order a home kit and have it shipped to your property. So this is not a new idea at all, but there are some innovations that are allowing us to do this better than attempts in the past. One of the big ones is flexible automation. So in automotive or other industries that do mass production, you have these very old school automation lines. They rely on robots that can repeatedly go to the same point time and time again. And so you spend a lot of effort designing these lines and programming the robots to do something repetitively. But over the last 5 or 10 years, with the advancement of AI models, better electromechanical control systems, we're able to design robots that, instead of doing the same thing over and over again, can actually adapt and do different things every time. They can deal with variability much better with vision systems, for example. And so one of the things we're doing is designing robotic work cells in our factory that can build a ceiling panel and a wall panel. They can build arches, they can build fenestrations, windows, they can add sheathing, and they can do this even with the very imprecise material of wood and framing lumber, which is notoriously not dimensionally accurate like metal. And so that's a really big unlock. Second big unlock is the software side. So the challenge has always been, if you're designing a new product, every single time you do a project, there's a lead time to that, right? You have to do all the engineering, you have to do the layout, you have to figure out every little piece. Using traditional methods in architecture, that's people drafting, cross-referencing against code, etc., and that just takes a long time. But with things like parametric CAD, so we use a CAD tool called Onshape, which is a cloud native CAD modeling tool that is really parametric at its heart and allows scripting inside the tool. We can create the logic in software that architects are typically applying to design buildings, and use that to very quickly generate variants. Layer on top of that generative AI and optimization tools, and you can really see how you can take a bunch of inputs for a site or particular zoning and then generate a compliant building very fast. And that's something that absolutely wasn't possible really even 5 years ago.
How do you think of when to try and solve something through hardware and robotics, and when to try and solve something through software, CAD, other methods? How do you think about the hardware software question?
Yeah, I mean, I think our bias is generally towards solving problems in software. It's case by case, obviously, but software iteration cycles are fast. Software is cheap to write and cheap to deploy by comparison, and it tends to be more flexible for that reason. Changes can be made quickly. And so when we can solve a problem with software, we want to go there first. At some point, you have to, in home building or any other manufacturing, you have to manipulate the physical world. And so, you have to solve the hardware problem, but you want to do that in a way that's designed to be flexible from the start. And so, like, a big premise that we are incorporating into our robotic system design is trying to use vision-based systems for identification and grasping of parts, like a stud, right? You want to scan the stud with camera or set of cameras or other sensors, determine where that stud is oriented, and go and grasp it, rather than a mechanical system to orient that stud. So rather than a big conveyor line and a jig that's going to put the stud in a known orientation so that the robot can maybe be more dumb and just grab it at the center. But the downside of that is that you've had to engineer this mechanical system. It's rigid, it's hard to change, it takes up a ton of space. And so as your product evolves or as new variants come in, it's very hard to know from the outset that you'll be able to accommodate them. But when you start with this kind of like vision-based approach, you're ready for that variability from day one.
You and I think both your other co-founders had experience at Amazon Robotics. How does that experience play into how you're approaching Reframe Systems today?
More than you'd think. I think, at the outset or on the face of it, shipping boxes and sorting boxes and packages and products doesn't totally feel a lot like home building. But what we got really good at Amazon Robotics was solving operational problems. So, Amazon operations, which did the fulfillment centers and the sortation centers that kind of process products and packages, they would come to Amazon Robotics with a big thorny business problem that they couldn't solve. Something like, hey, we need a building that can sort 30,000 packages a day, needs to fit in this footprint, needs to cost this much. And we can't find anything on the market that does this. And we would kind of go back to our toolkit, robotic systems we developed before, software we developed before, plus new tools or new innovations that we knew we had to develop. And we would package that together into a full building design. And so, we really were selling internally to the operations team, not a robot, but a building system that was capable of some like important business relevant task. And we did this, cycle and cycle again and again as Amazon evolved over the years and incorporated more robotics. That's really the skill set that I think we're bringing here. Is like we have a operational problem that we need to solve. It's a complex systems problem. It's going to require the deployment of lots of technology, not just like a single robotic cell. And that technology has to fit together into a building that's really efficient. So that's really the mindset that we're carrying over from Amazon, and why I think the experience has been really useful.
It sounds like you're really tackling this kind of end to end from like early design to, assembly on site. Like how much are you building in your micro factory? And then how do these kind of modules or pieces get transported and then set up at the actual building site?
Yeah, so maybe I can do like an overview of the process a little bit. It starts with a developer, which is our customers, our developers. So we're kind of like a B to B to C company. Developer has a site, hopefully financing, land control, etc. And then we start all the way at the design process. So we have product lines or product families that we've developed, but we are early in our growth. So we also design products from scratch if we believe that they have legs and fill a market need. So we have architects that kind of do all the typical stuff you would expect to get to a permit set and submit to a town and get approval. Then we have modelers, design for manufacturing and assembly engineers, software engineers that take that design and turn it into all of the manufacturing artifacts we need to power the factory. We have our 17,000 square foot facility where we produce wall panels that eventually get set on a floor cassette and form a giant box. Basically, these are up to about 60-foot long boxes, 12 to 14 feet wide. And these get finished to near completion in the factory. So we're talking, bathrooms installed, appliances installed, walls painted, windows installed. Pretty much everything we can do in the factory, we do. Of course, we have to leave some elements out because there's stitching that needs to happen on site. And then these boxes go out into our yard. We wait until all the boxes are ready, and then we have a set day on site. And so we just finished a project in Somerville, a 3-story, 3-unit building. And we had 28 boxes shipped to site. They were set within 4 days. And so the site really transformed from a foundation to an almost complete building in 4 days. And then, there's sort of button up and finishing tasks that happen after that. We handle all the site work ahead of that date, and then we handle all the button up and finishing after that date. And then at the end, we do inspections and get a certificate of occupancy. So it's a really unique approach that we're taking to really integrate the process end to end. But we believe that that's necessary for all of these systems optimizations that we're doing to actually bear fruit. If you're constrained to one part of the process, like, yes, you can innovate in your lane, but all the constraints of all the different elements upstream and downstream of you on the value chain, like, you have to respect those. And so your innovation is really limited to what you can do within those constraints.
If I put on my real estate developer hat, what's the value for me as a developer to work with someone like Reframe Systems versus kind of traditional building approaches?
It comes down to faster, cheaper, more predictable. That's really what it's about. So faster, we can do huge parts of the process concurrently that you can't do if you're doing site-built construction. Every single step of the process has to wait for the previous step to finish. But for us, we can be doing site work while we're building the structure. We can be pouring a foundation as we're putting the finishing touches on, floor 3 of the building. And so that just inherently takes time out of the process. So it's about 30% faster to go through this modular process for a given project than it would be to do to do site built. Cheaper is the second piece. So, because we're taking labor out of the process, both, labor in the factory and the field, but also on the modeling side, shop drawing side, architecture side by doing repeatable designs and using software, as well as cost out of the process by optimizing our product lines over time. So, removing material, making things easier to build, making the subassemblies simpler. We're taking cost out of the entire process. We're also not adding all the markups that a GC would typically add, right? Subcontractor is going to quote a price to the GC is going to add their markup on top of that. And that's like extra cost that's just coming from kind of coordination and the fact that there's multiple players in the mix. So our project that we finished in Somerville, even as kind of our second ever project, lots of startup costs and kind of one-time costs, already 18% cheaper than what our customer went out to market and bid that project for against kind of the traditional method. And we have line of sight to being 30 to 40% cheaper over time on that product line. And so this is just a huge benefit. It unlocks projects for developers that otherwise wouldn't pencil. There's actually a lot of developers now that are sitting on land. They have a portfolio of land. Land in New England is extremely expensive, especially in the Boston metro area. And a lot of times developers are sitting on that land because cost of that land plus the cost to build turns out to be more expensive than what anyone would pay, even in this highly inflated market. And so they just sit on the land, nothing gets built. And so if you can come in as a design build partner and say, hey, we're actually 18% cheaper today, or we're going to be 30% cheaper next year, all of a sudden those projects start to pencil. And they're like, oh, we actually can sell this project at a profit, and you unlock all of this kind of stagnant development. And that's, a huge part of what's going to get us out of this housing squeeze.
Is the idea that you're focused on like higher density urban infill plots or more kind of open green space areas?
Over time, if we want to achieve our long-term goal of solving the housing crisis, we're going to go everywhere. Today, we believe our model is especially well suited to urban infill, what's called missing middle housing. These are kind of 2 to 20 unit multifamily projects that really aren't getting built today because of that complexity. These are the markets where you need a lot of customization. You have to do that one-off project. Maybe it involves variances from the local zoning board. It involves a lot of permitting stuff. The sites are really complicated. And so for most of the big players, it doesn't make sense to build 4 units for all of that effort put in. Our model of mass customization allows us to do that much more effectively. And there's a ton of densification that's available in these markets. Like, this is where people want to live. And there's tons of plots that could be converted from a single family to a duplex or triplex. In fact, there's a ton of zoning changes that are going into effect as towns realize what a problem housing is. They're allowing ADUs to be built in the backyard. They're allowing things to be upzoned from single family to multifamily in a way that hasn't been true, since the 70s. But there's no one to take advantage of those projects. They're cumbersome. And most developers want to go, and home builders want to go big in some way. You either want to go to like multifamily and build 100 units, 200 units in a single project where you can justify all that expense of getting through the permitting zoning process, or you want to go really small, I guess, and do single family, but you want to do that on attractive land, 300 single family homes in a development outside of Houston, Texas, or something like that. Well, we don't have that in New England, so that's not really as much on the table. So we really think our approach that we're building lets us enter this segment of the market that really badly needed, where there's an opportunity to build densely, but just no one's kind of cracked the cost and complexity piece.
How about the value to the homeowner, the individual or families that are ultimately going to live in this robot built home? What's in it for them?
One big advantage of building in a factory is we can achieve much higher tolerances than what you're going to see on site. It's actually kind of crazy if you look at housing projects around, there's a lot of multifamily being built in the Somerville, Cambridge area, for example. If you look at those projects, they take some, several months to be fully framed and kind of dried in, meaning they're sealed from the elements. During that time, it's just raining directly on the lumber that's being built. That's obviously not good for the quality of the final home. You've got workers battling the elements to build these projects, freezing, snow and rain. And it just doesn't lead to as tight of an envelope or as precise of a building. Um, and so quality is a big piece. We've also taken the decision to really build homes to a higher energy performance standard and lower embodied carbon. And what that does for the homeowner is it lowers their cost of operating the home as well. So, it takes about a third less energy to heat and cool our home in Somerville than it does a typical home in the United States. And that just shows up directly in your energy bill every month. And then the last piece is, we build to a high quality standard. So we're a kind of upper mid market in terms of our finishes. And, we can deliver that at a lower cost, but it's like, these are not, trailer homes, right? It's not the typical thing you might think of for like a modular house. And so people are actually super surprised at the experience, the touch and feel, the kitchen finishes, the windows are like triple pane. We do pretty large glazing. So these are like big floor to ceiling, triple pane European windows, high end kitchens, high ceiling heights, all of this stuff. And so from a consumer perspective, this is a high quality home that meets the market in New England. And both developers and customers really like that.
You've been working on this startup for 3 years, I guess you mentioned. What have been some of the highlights and lowlights, either kind of business wise or personal wise, that you kind of look back on?
I mean, so many highlights for sure. You really put yourself out there when you start a company, because day one you have nothing. You have maybe a slide deck and a few ideas, and it's definitely tough to walk into rooms with suppliers, customers, towns and cities, and look them in the eye and be like, yeah, we're going to build housing in your town. And they start to ask questions. Well, what have you done before? Do you guys have a factory? All of this stuff. And your answers aren't too inspiring, even to yourself.
We've got a
And
garage in Andover.
yeah. And in some cases, we didn't even have that, right? We're calling up suppliers for big equipment purchases, and they're like, great, what's your location? What's your mailing address? And we're giving them Greentown Labs, which is an incubator in Somerville. And they're like, well, can you receive, do you have a dock door there? Can you receive heavy equipment? We're like, well, we're working on that. Yeah, it can be challenging, definitely, to like put yourself out there in that way. But it is extremely rewarding when you pull it off and when it kind of pays off in the end, and you're like, maybe people were skeptical or just didn't kind of see how it all works out. And then, we put a home in Arlington, and that was blood, sweat, and tears of a team of, 10 to 15 people, like working in a literal garage. Co-founders were sweeping the floors and running electrical and, pulling late nights to kind of get that out the door. And when your team's name and stamp is all over that building, and then it's in the ground and somebody moves in and has a home who wouldn't have otherwise had a home like that, it's just such a tangible feeling. And even though it's just one home and we need 5 million, it feels like those are probably some of the best moments.
Challenges, either kind of challenges ongoing, challenges that you anticipate coming up. What are the things that are keeping you up at night, other than maybe an infant at this point?
Yeah. So I have a three-month-old son, which definitely keeps me up at night. And actually, all the co-founders have kids. I actually have it the easiest because I just have just one. But both my co-founders have twins, and Felipe also has an older daughter, so all kind of under the age of 4. So it's it's been a bit of a wild ride in that respect, and I feel like I'm just catching up to them. But yeah, in terms of challenges with the business, we have so many. This is a really hard space, and many have tried and failed before us. So we are not the first people to have this idea or take a swing at this. There is a graveyard of startups, venture-backed startups in the housing space that have made it often to a successful Series A, sometimes B, sometimes even much beyond that. There was a startup in 2017, which is extremely well known in the space, called Katera. They were backed by SoftBank. They raised almost $3 billion, and they went bankrupt. And they built a lot of housing. They made a lot of progress, but they couldn't make it over the line. And I think there's some very real questions about, can venture financing really build a housing startup? there is such a mismatch between the pace of projects in construction and the expectations and the pace of technology companies and venture capital. Yeah, it takes many, many years to build. There's a lot of money that goes into it, and you don't get that many at bats, right? Projects happen a couple a year in the early days, and then if you're lucky, tens a year, or eventually hundreds of years, but a year. But if you compare that to most other areas that tech is applied, you might get thousands or millions of at bats to kind of iterate your product and achieve product market fit. And so it really feels like threading a needle, and it we don't take for granted that we're still around. We feel like every opportunity is pretty precious, and there's no guarantees on a Series B or beyond. So time will tell if we thread the needle and kind of make it out the other side. But we're certainly gonna we're certainly gonna try as hard as we can.
You mentioned you recently became a father a couple months ago. Congrats. Do you see any similarities or parallels between fatherhood and startup co-founder? Are there learnings that flow either direction, transferable insights?
The commitment and the buy-in is a big one. Just you have a child, and that first realization of like, wow, this is my life's project. Like this, I am totally bound up with this other person, for good or for bad, for the long run. Like we are in it together, and like I am here. Like I have a responsibility and a duty and a connection that didn't exist before and is totally inescapable. Like this is where my energy needs to go. When I'm feeling good, this is where my energy needs to go. When I'm feeling bad, this is where my energy needs to go. Like I am bought in. And a startup is not that different. You sign up, and like I'm not an employee. I'm not I'm not shopping around for other jobs. I'm not thinking about what to do next. It's just like we are all into this thing until it's successful or until it disappears. And that level of commitment and certainty really changes how you think about what you do every day. It really takes a lot of ego off the table when it's like it's all outcome. It's all just like, how do we make this thing a success? Yeah, I think there's a lot of parallels there. I actually think the startup life prepared me for fatherhood in weird ways.
If you could hop in a time machine and go back to 2022, kind of Aaron, just starting off on this Reframe Systems journey, what advice would you share? What message would you want to share with previous Aaron?
We have these. I have this flag that hangs in the offices at Reframe that says, "We do these things not because they are easy, but because we thought they would be easy." And I think you need a lot of that naivete to start something. So I actually feel like I might not say much. I think if I said too much, I think maybe I would scare myself off and wouldn't get here. And it's sort of the failure to appreciate how hard it's going to be that allows you to jump in the first place. So maybe I'll just stay quiet.
Maybe just a high five or something.
Yeah, yeah, yeah.
If people are still watching and they're intrigued by kind of what we've talked about, how should they get in touch? Or are there kind of a call to action that you want to put out there to the world?
So we're always hiring. www.reframe.systems is our website. We've got a ton of jobs posted there across every vertical you could imagine. We have everything from mechanical and software engineers to carpenters and electricians, construction folks, architects. So if if any of those descriptions or others fit you, like we'd love to have you on the team. So you can reach out to us there. If you're building at all in New England or in LA County, we're serving both of those markets today. So if you've got a project, kind of the 2 to 20 unit range that you want to get moving, like we're here, we have designs, we're ready to build. And then if you're an investor in this space, we've built a lot of momentum, we have a lot of great investors behind us, and we're headed towards a Series B sometime next year. So if you're interested in the thesis, reach out.
Anything else you want to share, or anything else we forgot to cover today?
We do factory tours every other Friday in our facility in Andover. We love having people through. It kind of changes it to really see the process and see what we're doing there. So you can walk through our units. We have a show unit out there. So if you want to learn more and are just curious, we're happy to host you. And you can find those on our website or on our LinkedIn. You can sign up for the next tour.
Thanks, Aaron.
Thanks so much, Jeremy. Appreciate it.